Good morning, dear students. Welcome you all to the JCE Connect series of online lectures. We are studying the subject elements of civil engineering and engineering mechanics. And we have finally reached the last part of module 1, that is a resultant of coplanar non-concurrent force systems, which was not there for your internals. So till now we have solved the examples which had concurrent force system. That means if you extended the forces, the point of origin of all the forces was same, or all the forces were meeting at one point, which was the center point where x and y axis met. So all the examples which we have solved were such that the line of action of the forces used to meet at one point. So now going further, we'll be concentrating on resultant of non-coplanar concurrent force system, where non-concurrent coplanar force system, where all the forces will be in the same plane, but they will be non-concurrent in nature. So it comes under moment and its application, resultant of coplanar non-concurrent force system. So in previous classes, we have already revised what is moment. So to brush up, let's once again see what is a moment. Definition of a moment. The turning effect produced by a force on a body is known as the moment of the force. The magnitude of the moment is given by the product of the force and the perpendicular distance. So that perpendicular distance is termed as lever arm. We have two types of moments. One is clockwise moment and other one is anti-clockwise moment. So if a force applied on a beam with the end as its moment center, about which moment we have to calculate, if the force is acting downwards as shown in the figure, it will rotate that red colored elemental beam in clockwise direction. Similarly, for the same beam having a moment center to its left hand side, if we are applying a force from bottom, what will happen is that beam will rotate in anti-clockwise direction, which will take as negative. So basically now in this first entire example will be as similar as the one which you have solved, summation fx, summation fy, and in the last part of the example, your moment concept and application of Varignon's theorem will come. So always remember clockwise moment and anti-clockwise moment. Clockwise will be positive, anti-clockwise will be negative. Now why I was stressing upon the previous part is, now in this type of examples also the starting again is resolution. Okay, by resolution you get the initial things, then comes the application of moment in this example. When we solve one example today, we will have a clear idea. So please be attentive, have a proper application so that the learning will be easy. And now on in the further classes, I'll be moving a bit faster because I've given you all enough time for understanding. Many of you all have put in serious, sincere attempt in your internals also regarding understanding and application, but few of you all seem to be not that interested. So now I'm letting go such students. So considering those good students who are interested, I'll be moving ahead a bit faster with the view of covering your syllabus. So this is what is moment. Moment is nothing but the turning effect. So now let's come to the point of today's class, wherein we'll be solving problems on coplanar non-concurrent force system. So a coplanar system is the one where all the forces are in the same plane, but non-concurrent means the point of origin, or when we extend the line of action of the force, those lines will not meet at the same point. That is what you mean by non-concurrent. So these are the steps which we'll need to follow in solving these directions. The good thing is that up to step number 4, all the things are nearly similar or the same. Okay, up to step number 4, you need not worry if you have studied properly for the internal, so you'll be able to cover. Then in step number 5, we are applying application of Varignon's theorem to find the x-intercept and y-intercept. These are the formulas. Okay, x-intercept means at what location the resultant is acting from the point under consideration in x direction. Y-intercept means at what point the resultant is acting from the point under consideration in y direction. And d is the perpendicular distance, the d distance which we have taken in your example, sorry, in your Variance theorem. This is the d distance. So now here, this is the reference sheet which you'll have to follow to solve the examples. Again, I am repeating, till step number 4 there should not be any much issue, because up to here we have solved many examples. Only this part you got to remember very much properly. X-intercept is summation of moments upon summation Fy, not x. Okay, x-intercept is summation of moment upon summation Fy, and y-intercept is summation of moments upon summation Fx. Okay, so this last point number 5 becomes very important here. So let us take the first example for today, or the problems based on coplanar non-concurrent force system. For the rigid plate ABCD subjected to forces as shown in the figure, obtain the magnitude and direction and line of action of the resultant of the system with respect to point A. This is a question paper problem which I have selected to solve. So this is a problem. We have a plate which is square in shape ABCD, and at each point some forces are acting. So if you take point A, there is a 100 kilonewton force going downwards. When you take point B, there is an 200 kilonewton force. So you need not convert kilonewton to Newton. You have to keep all the things in kilonewton only. Don't go for conversion of kilonewton to newtons. Let all the answers be in kilonewton only. So at point B, we have a 200 force which is inclined at 30 degrees. At C, we have a 100 kilonewton force, and at D, again, we have a 200 kilonewton force which is inclined at 45 degrees. So this is the given example, and we have to obtain the resultant about point A. Okay, that means the x-intercept and y-intercept, which we will calculate using the formulas shown on the previous page, will be with respect to point A. So this is the given example. So these examples will be a bit easy to read, not such an issue. Only you have to identify the correct point about which you need to calculate the moment. So let's go ahead with the solution. So first part, as discussed here, first part will be same. We have to find summation Fx, we have to find summation Fy, we have to find resultant, and we have to find theta. So now in these examples, this first 4 steps should be done very fast. Okay, because we have practiced. So for this, I'll go ahead and put this simplified diagram. Okay, for this step. So in this, you have all the forces which are resolved. You have to take the resolved components and solve for the summation Fx and summation Fy. Okay, so please start working and give me the answers of summation Fx and summation Fy. Okay, see the directions are there. So if you start from the point which you want, you can start and get me summation Fx and summation Fy. Same as you had worked out. All the components already I have mentioned there. So it will be like plus 200 cos 30 plus 100 minus 200 cos 45, which will give you summation Fx. And summation Fy when you want, minus 100 plus 200 sin 30 minus 200 sin 45 will be summation Fy. Please work it out and tell me summation Fx and summation Fy. Again, I am repeating, summation Fx will be plus 200 cos 30 plus 100 minus 200 cos 45, and summation Fy will be minus 100 plus 200 sin 30 minus 200 sin 45. The resolved parts are given on the sheet. Yes, anyone with the answers? Aishwarya? Aishwarya Hukkeri? Prajwal?
Yes, sir. Solving.
Sir, FX 131.78.
Okay. And FY? Solve.
FX is 131.78.
131.78. Okay. So now these parts are very easy. Okay, so I've started from this point. This is 100.
FY is minus 141.42.
141.42.
Yes, right. Monish, Akshata, you're right. Minus 141.42. Then you have to obtain the resultant and you have to obtain theta. Summation fx and summation fy becomes quite easy as we have solved a number of examples. So resultant of this is 193.30 and you get the tan theta. I think theta is not calculated. Just check out what will be the value. Is the resultant correct? Answer is matching 193.
Yes, sir, correct.
Yeah.
Theta minus 47.4.
47.02.
0.02. So now up to here, so in the exam also what will happen is if this question comes and if you get confused or what to do that question comes in, up to here at least based on resolution you can solve very much easily because that should not be an issue to solve up to here. Getting the resultant 193 and theta. So now next part will be very important. So those who all are solving, just write down the answers and concentrate properly on the next part because next part will be very important for the further sums also, where we'll be calculating the moment. So first task we have achieved, that we have found out the resultant and theta. Now we want to locate where in the resultant lies with respect to point A. For that we have to find the moment and use application of Varignon's theorem. So let's go ahead and find the moment. So this is the picture wherein all the forces now resolved, main forces are removed, resolved parts are kept. We want to find moment about point A of each force. First point, you note down and remember, important point, if the force or line of action of that force passes through the point under consideration, there will be no moment. Okay, that means any force or a line of action of any force, if that is passing through point A, that force will not cause any rotational action because definition of moment says force into perpendicular distance. So if the line of action of the force is passing through point A, that force will not cause any rotational action at point A. Okay, is that clear? So Akshata, can you tell me which forces will not cause rotation at A?
100.
Yeah, 100 force will not cause a rotation at A, correct? And
C. At C also 100.
no, that C force, does it pass through A if we extend? No, it doesn't
No.
pass, so it will cause rotation. So that force which we extend when it passes through A, if we extend and that passes through A, line of action of that force passes through A, that will not cause moment. Now if you see this 200 cos 30, okay, 200 cos 30 force, if we extend, it will pass through A. So that 200 cos 30 will not cause any much rotational action because what we want when the force is horizontal, we want a vertical distance. Is there any vertical distance between the force 200 cos 30 and point A? No, there is no vertical distance. So that will not cause any moment. Similarly, one more force which will not cause moment,
200 cos 45.
200 sine 45. Yes,
Yes,
200
sir.
sine 45. Yeah, sine 200 sine 45 force, because when we extend that force, it will pass through A. So it will not cause any moment. So first thing, when you solve the example, you got to identify those forces which will not cause any moment and don't take them in your equations. Okay, identify those forces which will not cause any moment and don't consider them at all in your equation. Otherwise, the sum will go wrong. Secondly, if we go logically, now as we said, 200 sine 45, it is a force which is acting downwards, or say it is a straight force, vertical force. So to find moment, we want a horizontal distance. Is there any horizontal distance between 200 sine 45 and point A? No, there is no horizontal distance. Now, if my point was point B, okay, say if my point was point B, then this would have been my horizontal distance. This would have been my horizontal distance with respect to this force. But now with respect to this force and point A, there is no horizontal distance. So this will not cause any moment. Similarly, this force, okay, which is horizontal, I want some vertical distance. Is there any vertical distance between this force and point A? No. Okay, when the force is horizontal, I want vertical distance. So it will not cause any moment. But now, if you see this force 200 cos 45, the force is horizontal and this is your vertical distance. Okay, the force is horizontal and this is your vertical distance. So this will cause moment. Okay, so that is the basic concept. Remember this point, and this will be applied throughout. Okay, this will be applied throughout. So now let's take one force and let us see whether it causes clockwise moment or anti-clockwise moment. Okay, so one more hint or the shortcut is we have to trace the shortest path how that force can reach point A rotational wise. Now this force, that is 200 cos 45, it will rotate in which direction? Anti-clockwise direction to reach point A. So see here, this force will come like this. This force won't go like this. This will be a long path. No, this won't go like this. Okay, this force will come like this inside. Okay, so 200 cos 45 will reach point A. So rotation, turning. So turn this force. Okay, in which direction I'm turning? Anti-clockwise. So it will be minus. So this is how we have to go ahead. Again, I'm repeating. So now come here. From this point, you want to reach which point? Point A, because point A is the one about which we are calculating moment. So where will turn? Like this only will turn. Because this way you cannot go. This is the longest part. No, that doesn't cause a moment. So this is the rotational action which will take place. Now it is which direction? It is anti-clockwise direction. So this will be minus. Okay, this is how we have to go ahead. So now anyone can tell me how will this 100 Newton force, 100 kilonewton force move towards point A? Which direction? Can anyone tell me? So if I'm going like this, I cannot come back. Okay, I cannot repeat the path. So this force will move like this. Okay, see again, I will draw this. Understand this point because this is not that easy to understand. See, move from the point C towards the arrowhead. So now either the force can turn like this or force can turn like this. But already I have come here in this direction. I cannot go back in that direction again. That will not cause a moment. So moment has to be continuous, free. So this is again ulta. No, this has to go like this. Okay, so this is how this force will turn to cause a moment. So which is this direction? Anyone can tell me clockwise or anti-clockwise with respect to this 100 force? Clockwise. Yes. So this will be plus. So horizontal force 100 and vertical distance will be this, which is 1 meter. So this will cause a moment 100 into 1. So now this is how we have to identify the rotational actions caused by all the forces. So I'll erase this thing. Now, can anyone judge 200 sine 30 force, how it will come towards point A, in clockwise direction or anti-clockwise direction?
Clockwise.
Clockwise.
Now I have come here up to here. Okay, so I cannot go like this, because already this way I have gone up. Again, that way I cannot come down. That cannot cause rotation. So I cannot repeat that path. I am going up here. So how I'll turn? Like this I'll turn to come to point A. So which direction it will be?
Anti-clockwise.
Anti-clock.
Yeah. So don't stress yourself much initially, because as we go ahead, things will become easy. So this force will go like this towards point A. See, you have to start from the origin of that force, go ahead, and then turn towards point A. So if you turn like this, what happens? You're repeating this path. Already you have gone up like this. Again, this turning effect is coming down in that same way. No, that lever arm will be affected. So how it will go? It will go up straight, and then it will decide from here. No, this way turn I cannot go, because I'll trace back the same path. So I have to go ahead, move, and go towards A. Okay, so this will be anti-clockwise. So this force also is anti-clockwise, and only this force was 100 force was clockwise. So you've got to understand properly how it will turn. Okay, how the forces will turn, you got to identify properly. So now just if you observe carefully, you'll come to know. Okay, if you observe carefully, you'll come to know. See, the point was on left hand side, it turned like this easily. If the same point we used to consider here, then what we had to do? Force will go this side. Okay, so it cannot go completely like this. It will be a too long path. So this is how it goes. I'm again repeating, it's not that easy to understand, but we'll make our sincere effort to understand the things. So once again, let me come to this picture. So we have three forces under consideration, which will be causing a rotational action. We have three forces under consideration. One is 200 cos 45, one is this 100 force, and one is this 200 sine 30 force. So we are finding the moment with respect to point A. Okay, so when I take this force, it has to turn in this direction. So this is anti-clockwise. Next, when I come to take this force, this has to turn in clockwise direction. So now, one more hint you'll get here is, see, these two forces are in the same line. One is moving towards negative x. This force is moving towards positive x. So their rotational actions also have to be different. They cannot have the same rotational action. Now see here, this force is going here. Third force which is under consideration. So I'll come from B point up to here, and I'll rotate in this side. Okay, so again this is minus. So we have got one positive rotational action and two negative rotational actions. Okay. So if you go ahead, this was anti-clockwise, this was clockwise, and again this was anti-clockwise. So here I have in the next slide, now one thing I have kept here. What happens? Is it correct or wrong? I want you all to answer it. Okay, I have kept a moment of 200 cos 30. This is what happens in the exam, and during valuation we see many times these things happening. Okay, many times we see these things happening. Now see here, I have kept this moment. It doesn't occur. See here, this distance is 0. Okay, 200 cos 30, as this force is horizontal, it will not move through this point. Okay, purposely I have kept it, because many times what happens in the flow, you will mark this also as a moment, because you'll take this coming anti-clockwise and you'll take this coming clockwise. But this is a horizontal force. Where is the perpendicular vertical distance? No, vertical distance is not there. So this marking should not be there in this. Okay, so this is wrong. Or if you take the marking, this distance is 0. because this force is horizontal. Is there any vertical distance between point B and point A? Is there any vertical distance? No, because both points are lying on the same line. So there is no vertical distance. So this is 0. Okay, so this is 0. So if you mark it, then you take it 0, it will be okay. Okay, if you mark it, then you take it 0, it will be okay, not an issue. But better is not to mark it only. Now similarly, this also. Okay, this also is written here. Sometimes the textbooks write it. So if you don't want, don't write it only, because say this force again, when I extend, it is passing through point A. So by mistake, if you write it, this distance is 0. There is no use of this. Okay, there is no use of this. There is no use of this. There is no use of this. So these three you can avoid writing. If you want to form the equation, you take them with 0. Again, it will be okay, but it will create complications. Now, this is how many textbooks give you all. So I have put this up. Okay, I have taken this from the textbook only. If you are damn clear, don't include that things which are multiplied by 0, because it will, again, you will put that in the calculator. Huh? I'm sure you are not confident that 100 into 0 is 0. You will put that in the calculator and do some silly mistake as you have done in your internals. 2-3 people at least I'm going to talk with you all personally. So nicely have solved the paper, but at critical points you have done such a silly mistake that, okay, your younger brother, sister in home who is in school also will not do such mistake you have done. Okay, so this happens. So be careful. So now what I'll do is, in this image, I have to remove this, but I have kept it to show you all that it won't exist. Because what happens is, in exam, maximum people do this mistake, because they nicely take this 200 into sine 30 minus, and they go ahead with 200 into cos 60 also, and they again take 1 meter distance. No, this force is horizontal. You want a vertical distance, so this will be 0. Okay, so now how we calculate the moment? Now the important things comes up. How we calculate the moment? So first is 100 into 0, because this 100 force is at point A only. So this will not cause any moment. Gone. Next comes R 200 into sine 45. This force is passing through point A. Again, this will not cause any moment. Again, this is gone. Okay, so these two are out. Then comes next force minus 200 cos 45 into 1. Now this force which we have taken, this is causing a minus negative moment. Okay, so moment will be force into perpendicular distance. So as this side is also 1 and vertical side is also 1, horizontal force 200 cos 45 into vertical distance 1 meter. So this is the moment. And why the minus sign is coming? Because the moment is anti-clockwise. Okay, the moment is anti-clockwise, hence the minus sign is coming. So from this point, which is D point, we are coming up to point A, and the force is horizontal. So we'll take the vertical distance. This vertical distance is nothing but 1 meter, which we'll use to multiply here. Done. Then next comes again this force 100. Horizontal force, again vertical distance between B and C, as it is a square, is again 1. This is 100 into 1. And next comes this force. Okay, this force, and this force is vertical. So the distance will be horizontal distance, which we have to consider. Again 200 sine 30 into 1. And this is anti-clockwise minus. So last force by mistake you have taken, okay, fine, you take it. 200 cos 30, but again distance becomes 0. So that will not have any part to play. Okay, so when you calculate, you'll get the answer of the moment as minus 141.42. So now formation of this equation, going ahead and solving, will be very important. So in this slide, I've tried to show you all what mistakes you can do, so that you don't do those mistakes. Okay, so that you can avoid those mistakes. Otherwise, these sums are also quite easy once you understand, but you'll do some silly mistakes and go ahead. So by instead of taking 200 cos 30 into 1, if you take, this answer will change. And again, the sum will go wrong from here. So you should not do that. So once we get this moment, we'll be using application of Varignon's theorem, that is d is equal to summation of moments upon r. So we'll get the perpendicular distance. This we have used in the theorem, solving the theorem. The perpendicular distance means the perpendicular distance between point A and the resultant. So if we draw a perpendicular here, what will be that distance? Then similarly, we find x-intercept is equal to summation of MA upon summation FY, which comes out to be 1 meter. And y-intercept we find out to be 1.03 meters. So this is modulus, so we are not taking the sign into consideration. Okay, so we are not much bothered about the sign. Okay, so this is what is we get x-intercept and y-intercept. So now once we get in here, generally the example ends here when we get the values of x-intercept and y-intercept. So this moment is quite difficult. I'll give you all some easy practice examples after this class wherein you can find the moment, so that the further examples will be easy. So x is 1 and y is 1.073. So how we mark it is like this. So which was our point we wanted with respect to A. So what is the x ordinate? 1 meter. So from here I'm coming here 1 meter. So this is 1, means it comes to D only, 1 meter. And y I have going 1.073, means if this is 1 up to B, I have to go ahead by 0.73. This is y ordinate which I am marking. Okay, from this A point, y vertically, how much I have to go? 1.073, means I'll reach somewhere here. So draw a line which joins this point and this point, which will be your resultant. This is how you'll get the resultant. Okay, this is how you are getting your resultant. So that is the application of Varignon's theorem in finding resultant of non-concurrent coplanar force system. So this last part is a bit tricky. You can stop the example here, no issues. Once you find x and y intercept, it is done. Generally, they won't ask the further things. But this becomes very, very important because you need to find the moments very much properly. Okay, so once again, coming to this slide where we had moment, we'll discuss how we found out the moments. And once you find out the moments, it will be very easy. So firstly, which forces will not be under consideration? 100 should not be considered. 200 cos 30 should not be considered. And next thing is 200 sin 45 need not be considered. So we are left with 1, 2, and 3 forces. Okay, so we are left with 3 forces. So now we have to check out how these forces will cause an rotational action. How these forces cause an rotational action, which is the moment. Vedika, are you there?
Yes, sir.
Can you please help me? This force, how it will turn to point A, clockwise or anti-clockwise?
Anti-clockwise.
Yes, this force will come like this. And how will you find the intensity of the moment? M is equal to force into perpendicular distance. So 200 cos 45, you will multiply by what distance? Force into perpendicular distance. So with respect to this horizontal force, which is the perpendicular distance, this 1 meter is the perpendicular distance. So how you get the moment of this force anti-clockwise? Minus 200 cos 45 into 1. Minus 200 cos 45 into 1. Now, when we come to this 100 force, this will be rotating in clockwise direction towards A. So this moment will be plus. How will we get that moment? 100, there is nothing cos sign here, 100. Now this is a horizontal force. Again, the vertical distance with respect to point A is 1 meter. This is again 100 into 1. So again 100 into 1. So this force, when we come, now it is a square, so distance is not a problem. 200 sin 30, it will go in anti-clockwise direction. And this is again vertical force, horizontal distances, this is 1 meter. So this is 200 sin 30 into 1. So minus 200 sin 30 into 1, minus 200 cos 45 into 1, plus 100 into 1 will give you the moment, which will get as 141, which is written here. 141. and then you find intercepts, x-intercepts and y-intercept. So this is an example where we try to understand how we will be applying moment in solving examples on non-concurrent force system. So here we plotted our resultant. So you'll have a lot of doubts. It is expected, not to worry, because this moment concept in classroom also it goes difficult for the students to understand. And here at least it will be more challenging and difficult. So similarly, now we will have one more example which I'll be solving in tomorrow's class. So today I'll be giving you all some working example just to find clockwise or anti-clockwise moment, how to find the moment, and I expect you all to solve those examples so that the next class will be easy to understand. So I'll evaluate your answer sheets, and I think by next class we'll be able to discuss about the internals. Don't worry about the answers what you have got. Don't worry much about the things which I've already done. Don't worry about your marks also. So this was the first example. So in next class, I'll discuss the further examples. So all of you can put your name and roll number for attendance and log out of the meeting. Thank you.